So, welcome to this session about innovation within bounds. I understand that I've been overly optimistic and ambitious to try to put everything of this into one half an hour. And that will not be possible, but I will do as good as I can then. So, and in this context, I am Frode Randers. I'm an IT architect at Försäkringskassan, the Swedish social insurance agency. I work primarily with data management in different forms, the operational data flows and analytics and things like that to keep the flow going, and also with applied AI. So I think I will be talking about both. So we are one IT department, but we're actually working for at least three agencies. So we are around 660 employees. We do a lot of work, a lot of development, and we do this for both the pensions agency and the public employment service, and of course the social security agency. I think the note down here, we pay out somewhere around 640 billion kronor per year. So that is around 57% of the whole state budget. So it's a lot of money coming in and going out, and that's pensions, primarily pensions, then social insurance, and then public employment. I'm going to talk a bit about change. I think I should start that one so I can keep track of time. And let's start with technology and IDs. So just to look back on where we are at the moment within our agency, I mean, we started somewhere long ago with COBOL, and somewhere along the line we picked up C and C++. These are the years when they were created, not when we adapted them. So we started as a COBOL shop, and then some 20 years ago we started building these multi-tiered solutions with C, C++. And what we can see is that the technology is constantly in a flux. There's always coming new ideas and new systems, new programming languages. And the problem isn't actually adopting one of these, but it's keeping them or keeping the competence as times go by. So in our case, we have problems with COBOL. There's not a lot of people knowing COBOL nowadays. And that will eventually happen with a lot of these languages. So if we're talking in the long term, this is something that we really have to calculate with and take consideration for. If we look into systems and databases primarily, I think we have been into all of these, or currently are. And this sums up to a lot of competence and keeping competence running. The idea is to use the best tool or a good tool for the job at hand. And as you can see here in the later years, there's a lot of things going on. And we use actually all of these. If we look into platforms, it's even worse. I mean, we started with this COBOL stuff, which is still ongoing, but we had to switch from Bull when that company disappeared, and we moved the COBOL code and the platform over to Sun Microsystems, and nowadays we're running this in Linux on Visual COBOL at the moment. A part of our solutions are running in COBOL I would not say that is the main part, but for the C++ and the Java stuff, we are using Tuxedo, or we use Tuxedo as a TP monitor. But we recently switched to Casual, which is an open source alternative. We are transitioning from VMware to containers, and when we had this Casual introduction or starting using Casual, we also moved the C++ code, these multi-tiered systems, into OpenShift as well. So even this adds up to a lot of competence and problems. So the problem isn't really getting new technology, it's getting rid of technology. So this kind of sums it up. So we had this COBOL era where we had this platform which is kind of pertinent or good for the time. We have been on to C++, and of course we have been doing a lot of Java with these middleware. And now we are turning into containerized microservices. The problem is that everything is there still. So it's extremely difficult to get rid of some of these old COBOL stuff. And the problem here is that some of these have been discontinued. So we have old systems where we have nothing going on, but people still lives. For instance, in the pension system, we have around 800 people getting 1,000 kroner from one of these systems. So that's 800,000 kroner per year. And it's not economic to do a migration of that system. And a lot of these systems are like this. I mean, you do not gain anything by migrating or building anything. You kind of wait for people. Yeah, kind of. Yeah. So we have this notion of, for everything new thing we put into the system, we have to kick out something. Well, this is really, really hard. Let's talk a bit about purpose. We have a general election every 4th year, and being a political tool, which these systems are, I mean, they are adjusting the floors and the ceilings of different kinds of allowances, for instance, and that means that we are continuously doing modifications, and these changes aren't really part of. I mean, if you compare them to the life cycle of the software, it's much smaller, these iterations, and we also have the regleringsbrev, the mission statement, where we every year get some kind of direction. What should we focus on? Things like that. The problem is the fast pace. So these periods or elections, I mean, they are much smaller than the life cycle time. And sometimes life kind of gives us a curveball, like the pandemic or the war in Ukraine, which kind of affected the price of electricity. So we have to cope with that. And that also means, translated into IT speak, is that we need some kind of flexibility. And that flexibility comes both in terms of functionality as well as data. So that really is one of the harder problems when we have these systems living for a long time and the requirements kind of change underneath our feet. On the other hand, we have legislation that is really, really, really old, and kind of informs how we do stuff. So I mean the public access principle makes us or demands of us to treat ärenden, cases in a certain manner. And that kind of affects how we work with them within the business area of the organization, as well as IT systems. Add to that GDPR and AI Act and all the others. So eventually you accumulate a large batch of legal or judicial demands or requirements that you have to cope with. What about organizational change? So I think I will just give you this is a model of an organization. I think it was done in the 60s. It's pulled into the limelight now and then. And the actual model was developed in order to explain why change didn't occur within an organization. So it's called the diamond model of Leavitt. And the idea is like a diamond, however you push it, it kind of takes up stress. So the idea here is if you modify the task, the organization usually adapts, but in a way so that the change that you are kind of wanting or demanding doesn't really happen. And also can say that actors are people within the organization. Structure is the organization, departments and how you organize. Tasks are what we are working with, and technology is of course technology. It could be paper and pen, and in our case it's computer systems. The problem is that ideas and concepts usually have this inertia. So that means in terms of paper and everything, in the 60s, we used papers and we had forms. And I guess in your age, you still have seen these paper forms that you fill in and send in to the agency in order to get parental leave or something. Nowadays we have moved to web, but internally, I mean, we can see the traces of handling paper. It kind of lives on. So one step would be to digitize paper, but it's still a digitized copy of a paper. So eventually reaching some kind of digital representation of information is really, really hard. And the legal system, for instance, with tryckfrihetsförordningen, kind of makes it hard to do this kind of change, because the law is it's kind of old. By necessity, it's old. So it's expressed in terms of this mechanism that was really, really good when we had paper, but not so much anymore. So within this model, information is a mediator of the what. And the task, of course, is related to the how we do things and why also. So my argument here is that the information bit is possibly the most important kind of concept that we can and should focus on. So even if we try or even if we modify the organization, we need to handle information, old information, and the continuous migration of information. So the usual way to do this is that you have this chain of migration as you go by. When you move from COBOL to something else, you move from the old database into the new, and you adapt the new schema. And that process of migration is kind of hard, because it can introduce errors and things like that. And the idea is kind of that from our perspective, from IT, information is something different than it is for the business. So you have a business view as well as a technological view. And the thing is, within the business view, information always lives in a context. It has a purpose. But what we need to handle is data, and we need to capture purpose and a lot of metadata around the data in order to make it reach our requirements. Yeah. So some observations is that data may have an even larger inertia than the organization itself. The ambition to migrate data as we go will likely fail, and it's sufficient that you fail once, and then you have a data quality problem as you go. And over time, I mean, we have systems, data that we need to retain for a lifetime plus 10 years. And I mean, that could be 100 years and even more. And seen in view of all this technological change, new databases, new programming languages, new IDs, object-oriented, it kind of makes this a hard problem. So maybe we shouldn't modify data. Also, data accumulates, and it accumulates in these systems, of which some are abandoned in different forms. I mean, they could still be needed, but they aren't actively in use. So we can't remove them. We need to keep them online. And also, data structure is king until it is not anymore. So this kind of is related to the need of flexibility. So, I mean, to keep data structured is of course important, but the problem is, as you go, the documentation, if you do not keep the structural information or the metadata somewhere around the data, you get a problem as you go. So we're kind of working or living in this continuum where we move from dynamic handling of data, or the dynamism of data, flexibility, schema on read. On the other hand, we have more structure, which is it is a cost really coming to this structural view. And the demand we have kind of changes, and it changes or it varies depending on what, of course, the use of the data. So talking about statistics, we usually want a lot of structure over here on the right side. If we're talking about historic data that could possibly need to be reused in systems, I mean, we need the flexibility to handle change, because we have these elections every 4th year and modifications, and both to rules and information. And also, when it comes as data needs actually to exist in all these kinds of forms. So the takeaway here is that we need all these kinds of different technology. So I mean, we're talking about stars and dimensions over at the right side, of course. We're talking about bits and bytes on the left. So, I mean, nowadays we're talking about lake houses, which is kind of a way to try to address this problem. So you have the data lake kind of taking care of the left side, and you have the warehouse taking care of the right side. In our case, we threw in graph technology there, which was kind of a lucky throw. I will talk a bit about that also. So connected to use, we kind of see it like having a demand or need to handle data in these operational data flows within the systems when we are kind of making our decisions. We are doing the core business of Försäkringskassan or the pension system or whatever, where we take in the claims and process them and come to a decision. At the same time, we need to avail this information for analysis or statistics in different forms. So we are kind of trying now to move from the above to the below. So saying that we need another structure where we mix these kinds of technologies in order to be able to handle data. And the idea here is not to lock data into structure. So as you see on the left side, I mean, we're talking about schema on read or other kinds of keeping control over structural change. So we have this stack with technology where we kind of mix this in order to generate different kind of benefits, and we see the need for this knowledge base on the top. So we're establishing that at the moment, and it kind of falls into this into this realm in this way. I think I need to speed up this. So let's talk a bit about what we have done in order to kind of handle this. So one is using our software model where we capture our services and systems and subsystems and applications and code and everything. So what we are doing now is that we are data mining all the code base, the COBOL, the C++, the Java and everything. And everything goes into a graph. And from that graph, we can pull a lot of context. I think this one is really one of the nicer graphs. So this has been an eye-opener, really, to use graph technology in order to see all the complexity in the code base. And these are information information paths between the components of the system, and kind of shows the problem we have with maintaining and retaining data over time. So the problem here isn't so much to migrate data as we go, but to kind of handle or providing flexibility in the way we handle data. So a bit about AI. So how can we handle change when the organization kind of locked up in the ideas of how you deal with problems? So we have innovation money that we can invest in new ideas, and we have invested a lot of money into AI. We started in 2017, 18, around there, and we had the first system in operation 2019, which is the one I'm going to talk a bit about. We started with a lot of proof of concepts, and what we did was taking the technology, making these POCs, and threw it on the wall and see what stuck. So I mean, we did a lot and trying to see whether our organization would pick up on the ideas and do fancy stuff with it. So this is one of the things that really stuck. So just an expose. If you apply for aktivitetsersättning, that's part of the old sjukpension, where you are kind of given money for the rest of your life because of some serious something. I mean, you could have had a stroke that influence the way you can handle work, really. That's the main thing. So what we usually did was pulling information from these forms. So even if this seems like a paper, it's not really. It comes as XML files from the healthcare organization. But the problem that we try to deal with is classifying the descriptions of problems that this patient has, and try to see whether or how this could affect your possibility or your work, how you can deal with work. And in this case, I think this is an old. So the problem here is trying to map this from what the doctor has described into some kind of classification. That's one step in the analysis. And this is kind of difficult. So we have a lot of people working with this, and they can be oldies, having done this for a long time, and also they could have been newly engaged and in our organization, started working and end up with having to kind of do this work. So what we needed was support for inexperienced administrators, but we also wanted to equalize the way we treat these. So I mean, you get a fair treatment. So it doesn't depend on which administrator you have gotten. I think more of the same. Yeah. So to pull information from text and do this classification. So this is how it looks now with the system that we have provided. So on the left side, this is what the administrator sees, and from this diagnosis, you can see that there are a list of different functions that may be or is impaired. And that list is based on the information that the doctor has given. So based on the information the doctor has given, we do a classification task using a deep language model, deep learning model. And you can also, if you pick or select the function on the left, we will light up the text in the doctor's description that made us make that kind of conclusion. So the administrator works with the system, but on the right-hand side, we have the handling of training material on the creating training data using experts. So that's subject matter experts working with and typically very experienced people. So they work with production data or these medical statements, and they will make a selection based on diagnosis, go through this, pick out text from these statements and map them to these ICF classification codes. So these are feature and state and target. And this is a continuously ongoing task where they work with the training data and looks at feedback from production and sees whether they need to train more, or if there are certain classifications that we need. So at the moment we have mainly focus on psychic, for instance, psychic functional disorders. The training data is given to us, to the IT department, where we train the model, PyTorch. So we have GPUs in our computer center, and we base it on a language model that understands Swedish. So we are fine-tuning that model with the training data. We sit together with the business and do the evaluation task, because only those can answer if the model is really working as expected. And together we make the decision to take the model into operation. When it's in operation, we track the behavior of the model, and that behavior, the monitoring of that model, makes input for us how to deal with the training. So if we see that there are some classifications that aren't really good, then we can train more. So this is a machine learning pipeline that we have introduced to, with the business work with retrieving production data, classifying, analysis, and then labeling. We have the training and the evaluation and making decision of publishing it for production. We have this continuously ongoing monitoring and the feedback loop, where we kind of feedback the results of running this in production into the training phase. So the takeaway here is that the hard part isn't really PyTorch or AI. The hard part is the training data, keeping track on training data, and the AI Act from EU demands of us that we have traceability in all these steps throughout. So we capture who did the training, who made the decision of this going into our training set. We keep track of what base model we are doing the fine-tuning of, what model is in production, the performance of the model and everything. Produces huge amounts of data, but that's another problem. I think I will just skip that one. Some other uses to round up this. We talked about this proof of concept, so we did a lot. I mean, image to text, form to text, speech to text, and vice versa. So we got help doing this, and so we could demo it. We did a lot of text analysis, sentiment analysis, and things like that. We were playing with language translation and also image recognition and classification. So I think this is from a doctor's X-ray, where we have had problems with dentists claiming money and sending X-rays where they say this is proof of our handling of this patient, and then we can see whether that treatment has actually been given. So this is a root canal, and if we don't see a root canal in the image, you cannot necessarily have done that in. And some of these were put into use as tools. So we had taken, for instance, a part of speech and named entity recognition. That was combined into a tool called a PII masker, where we can use PII as personally identifiable information. So we can throw text on it, and it will come back and say whether it contains PII information. It can tell what kind of PII, a telephone number, an address, a name, and we can ask it to mask this in different ways. So the tool is kind of versatile, but it's built on this basic functionality. We're also doing synthesis of text, going the other way from classification, and that is an experiment for some of these functional departments where we see that where we don't have really enough data to train on. So the last picture is, I mean, AI is a really wide field, and we see that we are heavily invested in deep learning and language models and the classification parts and things like that. But we have been around, and we know how to do this. Some of them haven't really been put into use. For instance, we have this idea of taking audio and generating text and making a feedback into the loop when you are seeking job at Försäkringskassan, to kind of direct what questions to ask and things like that. We have to see where that ends. So that was my last picture, and I think we have 4 minutes left. Yeah. Do any of you have any questions? I can just conclude that I didn't maybe make true on my promises to answer all these questions. They were too optimistic and ambitious, but hopefully you have something to take away from there. At least get a feeling of the problems that we are working with and how we try to deal with them. Yeah?
The first slide when you moved from some microsystems, now you have Linux.
Yeah.
You also have a problem within Linux versions?
Yeah.
Moving between Linux versions? Or how do you try to do that?
Yes, so the question was if we have seen problems with Linux versions. Yes, and I mean, we have been using Linux for quite some time, but we have sided with Red Hat, and so I mean, we have the Linux, Red Hat Linux, and all these others. So I mean, when we have met problems, we have kind of yes. Really. So, and also, yeah.
What about integrations? You have so many systems, so many platforms, applications.
Yes.
Have you got a common way of integrating? Is that also?
Yes. So the question was if we have a common way of integrating systems. Yes, and traditionally we use Fuse, and and some other open source components around that. So we have this central kind of integration going on. Different kinds, migration or translation of version or protocols and things like that. And what we see now is that we kind of doing a pushback to the original systems, the source systems. So we see that we want to go back and say that you have this API and you no need to accommodate for another kind of API. So the problem, one of them was that with a central team keeping track or doing integration, they kind of became responsible for both the integration as well as the data. And that made it difficult, really. So what we are doing now is one of these organizational kinds of tweaking, where we are pushing the problem back to where it really belongs. Also, we see that integration is much related to, of course, data, and so we try to centralize some of it. We are enforcing structure. And for instance, by actively working with master data. So hopefully we will not need so much integration going forward, even if we have all these technology platforms and what that kind of entails. Any more? Okay. I think I was actually on time. Oh.